Yo, 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 what's up? Happy Friday. Let's jump right in. What I want to start today with is I want to get this water to work when traversing terrain patches. I think we have a solution. We're going to get to it. Oh, fuck, did I screw that up? I just want to start by showing the problem in question. Yeah, there we have it. So the values between two terrain patches doesn't really generate accordingly when we do the fluid solver. I explained it yesterday. I'm just going to explain it quickly today as well. This one and this one are so-called twin points of terrain. So the thick line here represents different terrain patches. We have 4 different terrain patches. What up, Cooler SK? Each terrain patch has 4 pixels or data points. So this data point and this data point will represent the same value. At a intersection like this, when we have 4 terrain patches, this let's see here, this one, this one, this one, and this one should represent the same value, i.e. if this one changes, these 3 should change as well to the exact same value as this one. Then we have this one and this one, and then we have this one and this one. So it's pretty much a flow should only be able to happen between terrain patches between twins. So from this one to this one, but not from this one to this one. So we have to add that constraint. And also, when we flow from one point to its twin, we don't want to do any water dispersion or anything like that, any of those calculations. We just want to take whatever value we have here and put it in here. So it's 2 things we want to solve. What's up, Prana? Water should only be able to traverse from one terrain patch to another using the twin data point. And when it traverses using the twin point, we just copy the value. That's basically what we're going to do. Exists infinite amounts of solutions to this, but I think the easiest one we're going to start with today is just utilizing a global indexing system. So right now each terrain path has its own indexing. So this one is 0, 0, 0, 1, 1, 0, 1, 1. The same for this one. 0, 1, 1, 0, 1, 1. So if we compare the local indices to figure out a twin point, you can see here that it's wrong. These 2 don't have the same indexing. This one actually has the same with this one, and they are not twin data points. But if we add a global indexing system, so this terrain patch is 0, 0, this terrain patch is 0, 1, this one is 1, 1, and this one is 1, 0, then we can use this indexing, so the terrain patch indexing together with the data point indexing and the resolution of a terrain patch to calculate a global index which we can compare. And it's basically gonna be let's see here, patch index x times resolution of the terrain patch plus x, and patch.y times resolution. We can actually have different resolutions, so let's name this one rx and this one ry plus y. So when we calculate the index for this one, we do so for this one, for instance, it will be 0 times 2 plus 0, so 0, and then we will have 0 times 2, or 1 actually, we want to go -1 on resolution, plus 1, so this one will have 0, 1. If we do the same for this one, it will be 0 times 1 plus 0, so 0, and then we will have py, here we have 1, so we have 1 times 1 plus 0, so we will get 1. And we have a match between these coordinates, and it should work for more complicated or points further along both axes. I'm a little bit I'm pretty sure. I'm wondering about this one. Zero, zero. Yeah, we'll get 1, 1. Okay, so the first thing we're going to do is jump to terrain patch. We're going to add a function for this. So we have index, that's one-dimensional index. Do we use this one? Yeah, we do. Yesterday I also said that we could use position object space, but we're working with float values here, and I don't want to do comparison between floats. So public vector2int index global. We have a small index and a big index. Yeah, we might want to rename this one eventually. Index.x times resolution -1 plus x, and index.y times resolution -1 plus y. So when we have index global in terrain point, we have a method called isTwin with terrain point n. Here we can just return not position OS, but index global. Index global. If these are equal, we have a twin point. So now we know. Oops, sorry about that. We're also going to have a public spool has same we have has same terrain patch as point and is twin with terrain point. So let's change this one to terrain point as well. So now we have the two different calculations we need. Because remember, when we traverse terrain patches, we only want to traverse it if they are twins. So we need to figure out if it's a traversal of terrain patch at all, and if so, are they twins? So if we go to the fluid solver, we have spread fluid here. And I'm pretty sure we want to do calculate fluid spread amount. We could either do it in here, so if we traverse terrain patches and it's not a twin, we return $255 or something here, or actually minus infinity, but that's not a very clean way of doing it, I don't think. Or is it? If we take a look at it, we have a lot of different sub-steps here. We have find reachable minima, where we spread fluid. Yeah, I want to try to do it here. So calculate fluid spread amount if P has, what is it? P dot has same terrain patch as terrain point N. If this is not true, then we want to check maybe this is not the cleanest way to do it, but if P is twin with terrain point N, this is where we want to do a proper spread. So let's do it like this. Return calculate fluid spread amount. Here we're just going to do p.getValue type. Otherwise, return int min value. Returning int min value here should lead to this one always being false. So we should just return false. That's not entirely true though, so this won't work. Or actually, will it? Yeah, it might. This might work. Let's try it. Okay, what we get instead is we don't have any flow over at all. Water 0.4, water 0.4, 0. Okay. Why? We're gonna do this. Let's see if global index works. So we're gonna do X, Y. Let's see here. Good morning, Calvino. Local X, local Y, global X, global Y, let's do it like this for now. Let's see what global indexing we got. What's up, Gigi, Sammy? Global 260, 254. 260, 254. We actually have the same global here. Two 254. 254, 260. 254, 260. 282, 380. Ah. 282, 381. 282, 381. Okay, so global does seem to work. So yo, what's up, Geralt? Happy Friday indeed. Index global works. Vector 2 int comparisons should be overridden, so this one should be correct. So calculate fluid spread amount. They don't share the same patch, but they are twins. Ah, fuck it, let's do it like this. This one happens because we get this int min value sometimes. But does this one ever happen? We can double check it with a print soon. Let's see, is twin with terrain point n and p get value. So let's say that it happens, then we have fluid spread that is the same value. We hope this is true, then we set it. Yeah. Twin. If it doesn't happen, I'm pretty sure it should. Interesting. which means that x and y... Fuck, are we not referring the same... Yeah, it's this one I'm a little bit worried about. But I don't know. So if we have 128, it should be 0. This is true. (128), we have 1 here. 1 plus 127, 128. Yeah, we get 1 here. I'm worried about this one. We looked at this method yesterday as well, and I remarked on resolution -1 here. I just need to make sure 128 should be 0. -1 should be 127. So if we have a resolution of 128, this one is 127. So we have 128 modulus 127, that leaves 1. Plus 127, so this means that this one is 128, which means that this is 127, which means that we get 1 here, which is not 0. But if we send in 128 here instead, we get 128, 128, that's 0, we get 128, 128, we get 0. -1 then, we get -1 here. Should be, so this one is -1, we get 127, and we get -1, we get 127, we should be getting 127. Yeah, I'm pretty sure this one has been wrong the entire time. Previously, or I hope it has been, previously we have only used it for calculating normals, so... But one sec. Yes. Oh, that is true, that is true. Let's see here, get index wrapped, terrain patch and terrain point. When we use it to calculate normals, so if we want to calculate the normal for this one, we want to use this one, this one, this one, this one. No, we want to use this one, this one, this one, this one, this one, this one. This one, this one, this one, this one, this one. Is that true? 8, Yeah, it's a problem of the other way around at this time, because when we do this, we like when we calculate the normal for this one, we don't want to use this value because this one is basically this one. Interesting. So yes, when we calculate the normals, we want to use all the ones that are not twins. So this one, this one, this one. This one is the same as this one, so we want to use this one instead. This one is the same as this one, so we want to use this one instead. This one is the same as this, or this one is the same as this one, so we want to use this one. We want to use this one. We want to use this one. 9. Fuck. Yeah, these two are the same in this case. Ooh. Okay, so when we calculate the normal, let's do it like this. When we calculate the normal for this one, we would like to use the value here, 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 and here. And then we check. We use this one. We use this one. And we use this one. But here we traverse a patch. We don't want to use this one because it's the same as this one. So we do one extra step. This one is equal to this one, so we don't want to use that one. We traverse an extra step. We don't want to use this one. Here we're traversing 2 because it's the same as this one, so we do this one. Here we don't want to use this one because it's the same, so we use this one. And here we don't want to use the same because it's the same one. So we use this one. And the previous calculations worked great for this one because this is how we step it. So if we overflow in the x direction, we do one extra step. That's why we had resolution -1 here. But if we want to get the correct index wrapped, this is not correct. So I think we just want to do I think get index wrapped. Oh, one sec, we want to do it for we did it for y. Okay, get index wrapped. Offset, the naming of that one might not be the best, but I think this is how we want to do it. Could this have screwed it up in other ways as well? Maybe. Yeah, I think so. Water 0.4. Okay, I think it spreads in the correct way now, but we still have this black rendering going on, which I'm very interested in. Okay. Don't we find a minima? I need to fix that one. No, it's not entirely correct here. 3.8, 3.7. Because we have a mismatch here. 222, 255, 222, 254. It's correct. But here we have water 0.38, water 0.37. This one actually has more water. Why don't we get... It looks... I wonder what the fuck happens here. And it looks like we get the correct water values on edges. Want to get to the bottom of this one as well. The black bar. Okay, the black bar is definitely one problem. But it's a problem that, like, I anticipated. We probably have some, or I might know the cause for. But when we get weird edges like this, on the other hand, or an even better example would be the one way over here. Didn't we have it here somewhere? This one, extremely ugly, but that's not the ugliest one. Oh, one sec. Like this one, for instance, we have more water than height, but we still don't have visible water. And here we actually have a problem of it not traversing accordingly. Or actually we do. Water 0.4, water 0.4, but what the hell is happening? Why would we still get a mismatch here? Is it because... Yes. Okay, yeah, here's another... bad thing, or negative aspect of flipping the quads. That means that two neighboring quads that should be the same might have a different flip, which means that we might have a problem. I want to disable that one. Ah, that's unfortunate. Terrain fluid solver, flip. Don't we have that here? Flip. Update fluid mesh data and flip quad. Flip quad. Fuck, do we call this one here as well? Yeah, gonna have to find a better way to do this. Unfortunate. So these damn edges are gonna suck. But now we have water flowing between patches at least, but this... Ah, fuck me. Interesting. Where do we have it? Why do we have a mismatch here? $447. Okay. Yes. How could this happen? So here we have a point that is, we don't get enough water here. So we get a water value of 0.44. Same with this one on this patch, but here we have a less water amount basically. It's because we try... This point fucks it up. Why? Yes, okay, because this one, I think this one gets its water from this one, and this one gets its water from this one. Okay. Okay. What can we do about that? So it's pretty much like this. Let's say that this one spreads. We try to spread here, we can't because we're traversing and these two are not neighbors. We try to spread here, we're traversing, so we just set the same water value to this one. But how does that work? Let's see. Yeah, it's pretty much like this. This one traverses to here. But it's not enough water to be great. It's not the water amount is not greater than the height, so we don't draw this one. Then we traverse here, and this one we lose some water here, so 0.1 we traverse here and set the same value, 0.1. This one we don't traverse, this one we traverse. This one tries to traverse here, we can't because this one is less than x. We try to traverse here, we can't because this one is less than x. This one never traverses because this one doesn't have enough water to. But then this one traverses here, so we get 0.1 here, but this is less than the water amount, so x1. And now we're at a case where x1 is, or x is not equal to x1. And we get a little bit of a different height difference in the mesh. What I would like to set, so as soon as we set the value of one of these, so as soon as we set this value, we just set this one to be the same. But the problem with that is that we also need to add these points to points that can traverse. So yeah, it's this one. Spread fluid true, which means that we would like to check these things here. So instead of doing it this here, we want to do it here basically. Would that solve the issue? No. But I wonder if we could do it, if we can do this sorting way earlier. So here, get neighbor. If we could do some checks here. Yeah, the problem is that we spread the fluid here, it's not enough, so we can spread it here. But that's also a problem of how we handle edges. Currently we set the edge values so If we currently we set the edge values based on neighboring water values, and that is because we wanted to, let's see here, reduce edges and stuff like that. If we set it based on height instead, we have a much better. If we just set it based on height, so not the spread itself but the height, then we will get the same value here as here. Without the flip quads, it will probably not matter that much. But we want to do it like this because we want to do the normal calculations in a good way. Yes, that is true. But then again, now we don't even use let's do procedural water. Okay, this explains this one. Yeah, we have these normals. If we would go ahead and do terrain fluid solver, so when we spread fluid here, if this one is false, I don't think we can do this in a nice way without using all the neighbor points. head. It's this. It all comes down to this. For this edge water point, we base the height on this one. For this edge water point, we base the height on this one. These should have the same by default. It would be easy if we just when we set this one, we set this one automatically. And do everything else the same. So when we instantiate this one, we can probably get neighbors. When we instantiate it, we calculate neighbors and twins, but the problem with this one is, or by doing it like that, is I want to get rid of terrain point. I don't want to increase the dependency of terrain point. it's pretty much, as soon as we do this, we also set the value of the twins. Yeah, that would be pretty much it. Terrain fluids, how we do it 2 times. Check for water overflow. But then we're gonna set it twice, yeah. Maybe we should just go with a ugly solution for now. Okay, if we allow for increased dependency on terrain point, so that we calculate the neighbors initially. So when we create this one, we calculate the neighbors. We remove or add neighbors based on this one. Oh, fuck it, let's try it. But one sec. Now, if we do that, we're pretty much gonna recreate the entire terrain with multiple terrain points representing the same points. Yeah, that's not sufficient at all. Could we remove dependency on terrain point by doing this entirely with global coordinates? But if we do it entirely with global coordinates, we're gonna have to utilize terrain base for this. But maybe that's okay. Have a terrain fluid solver in terrain base that handles it. Maybe. Instead of a singleton. Maybe that's not too bad. Would it have... now I'm pivoting way too much, but would it be... this could be a possible improvement to the fluid solver. Like right now we disperse water from one point. Like it's almost like we push water to its neighboring nodes. I wonder if we add water to one point, we take all the neighbors, and then for each neighbor we fetch water from neighboring nodes instead. But would this help with this case? Yeah, it probably would. Yeah, but I don't want to do that now. So let's leave this as is and look for solutions for the current implementation. And it pretty much comes down to how we want to handle edges that has twins. I mean, we could possibly... Yeah, it's basically... If we add twin logic here and we add twins here, even though we don't get a proper flow. So something like this. We would add water to this one. Here. And but that's also wrong, because then this is not true. Now the best straightforward would probably be to, okay, so if we add water to this one, we're not above ground level, then we check the neighbors of this one, we take the ones that are twins and set the water to be equal. But that means that for each point, for each stop point, for each edge point, we also traverse all of its neighbors. It's gonna add a lot of computations. Unnecessary computations in most cases. It's probably just around 128, so in this case 16,000. We're just gonna add it for, what is it? We're gonna do a lot of computations, which are pretty much just needed for 3% of the total amount of points. Yeah, that's rough. But I have no doubts that it would solve the issue at hand. But there must exist a better solution. We could we do it in some way? So when we get the neighbors for this one, we currently get this. When we get the neighbors for this, we currently get, let's say that this is the full terrain, and we fetch the neighbors for this one, we currently get this, this, and this. What if we also pack into this and this? Actually, we get... What if we got all of these, based the spread value on global indexing? Calculate fluid spread amount. Height. Yeah, we always assume. Yo, what's up, Travis? How's the project going? It's going pretty good, I would say. I don't know what I was working on last time you were here. Dry constant diagonal cost. Distance. Yes. So here we would like to do distance between global coordinates instead. It will work with terrain patches if we do global. I'm pretty sure, yeah, it will. Because this one has the same coordinate as this one and this one and this one. So yeah, we could probably do that pretty easily. The only problem is so when we spread the fluid from this one, traversing terrain patches, not entirely true. So we would probably want it when we spread from this one. We also spread to neighbors. But then how would it look if we spread to this one eventually? Or when it's this time to spread, we don't get this one. What a annoying problem to have. Honestly, I'm thinking edge point, edge point. It's only edge points that screws it up for us right now, so I wonder if we just skip flowing to edge points for now, but we mark them as edge points. Because I think we want to save edge points eventually as well. So what if we don't spread any fluid to this one, just mark it as an edge point. And then we do some other calculation with the edge points eventually. Because I'm thinking let's see here. Maybe that's the best. So we still do this. And then let's see. First we do find reachable minima. We should be finding this one. And then we check for fluid overflow. And finally we update the stable fluid state. I have one task with this fluid solver that, or one optimization task that I've been wanting to implement, which could eventually help with this problem. Most likely, actually. But I'm just thinking if I wanna... It would need some reworking here, and I'm just wondering if I'm ready for that task right now. I don't think I am. I want to leave this one as is for now. Which means, let's just do a quick fix for this shit and move on. So of the many quick fixes, which one do we want to go with? Let's see here, what do we have for our normal calculation? Let's just do it like this actually. Terrain fluid solver. Update stable fluid state. Affected points. Spread fluid. If this one fails, this one fails if this. So here we can just do, if it fails, so it's basically what I'm getting at is if we try to spread towards this one and it fails, then we just take the maximum water value of all its neighbors. We do the same with this one eventually. So we take the maximum water amount of all its neighbors, and that's how we do it. And since we're always moving in the path with the least resistance, so when we get to this point and we take the maximum water amount of its neighbors, we don't have a water value here yet, but that doesn't matter because when we eventually get here it's going to be less than this one, I think, most likely. So let's see if this quick hack works. Since we implement it here, though, it will only be when we calculate the final stable state of the fluid. So we might get some progressing that doesn't look as good. Do I care about that? I don't think I do. Let's just try it. Oh, we already have M. Work with bytes. Something like this. So if we take this example, for instance, when we are at the last stage and we're fixing the stable fluid state, we try to move this fluid here. It doesn't work, so we set. We take this one and we set it to max out of this, 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 this. We get this one, and then we do the same thing with this one. So we set it down max of this, this, and it will probably be this one. I sure as hell hope. But this solution, even though it might work, it highlights a thing in the fluid solver I'd like to rework. And I was talking about an improvement I've been wanting to do for a while. concerning the water terraforming, and I think it's, let's see, yeah, definitely, but don't I have this one here? Oh, fuck it, I'm gonna have to write it later on, but basically it all comes down to the fact that each iteration is basically an empty sheet of paper. It's probably better to do it like this. So basically we add, let's say this is the minima, so we add a water amount here, and then we spread it to its neighbors, and maybe we get something like this. So this is the first iteration. What we do in the next step is that we add water here again, but we add a greater amount of water, and then we just do the same iterations again. So we spread this water to this one, and then this one, and then this one. So we do all of these calculations again, and then we get to maybe some extra spread. So basically we get something like this. What one could do instead is that we store all these points as traversed and completed points, and these as our edge points, this one as well. So when we increase the water amount, we just add that water amount to these points, and then we start traversing from these points basically. What's up, myself? Thought this was Karnal map for 1 second. I have no idea what that is. But let's check it. So we're talking about this. We're basically gonna have that when we implement this solution. We're gonna have, it's not really Boolean, it's more like, we want to have 3 values, so, but yeah. Okay, what happened here? Let's see if we have, so the only thing, we might get a fucked up result mid calculations, but end result should always be so I thought. Edge point, water 0.4, but our edge point doesn't work for this one. The development is coming along, it does, but we just noticed one little problem with the fluid sim, which I want to fix. Do we really get wrong normals like this? Water 0.54, water 0.54. Yeah, what's up, Lee Evans? It's probably gonna be a couple of years until it's done, though. Yeah, I fucked up 0.54. Yeah, I did. Okay, this one doesn't make any sense whatsoever. Water 0.54, height 0.41, but we still don't see any water. Water. Yeah, we still don't have it completely done here. 0.54, 0.54, 0.54, 0.54, 0.54. We actually have the same amount of water, but we fucked up with this one. I fucked up with this one. Vintena, yo, what's up? Good morning, good morning. The other day you published a video that you then deleted, or am I god? I don't think so. Pretty much every weekday I publish live streams. Every Friday, if nothing unforeseen happens, I publish a short. It's been a while since I did an actual video though. Okay, this one doesn't fix it at all. Did we make it worse with this one? Sure as hell looks like it. Fuck, am I actually gonna spend next week improving and optimizing the fluid sim? Water 0.4. Water 0.4. Vintana, by the way, I love the design of your character. Good job. Thank you, appreciate it. Yeah, I'm quite fond of it as well. What the hell do we have here? Yeah, this is extremely wrong. And it doesn't represent what we see. Water. How the hell can it go this wrong? Update stable fluid state. Spread fluid, yes. Update stable fluid state. Swap data channels water and water previous. So whatever we have in water, we put in water previous. Fuck yeah, we want to clear this one as well. Bool apply false. MP. We take whatever we have in water and put it in water previous. Okay. Update fluids, fluid amount, set value water fluid amount. Oh. Huh. Myself, do you stream at YouTube too? Yes, I do. Yes, I do. This might... Okay, so let's take a look at this. Before we do the final water state, we swap... Do we clear water previous? Or do we... No, we don't. Apply data water... Water. We just swap data channels water and water previous. Why? How the fuck? Yeah, this is fucked up. We probably want to do a... Wouldn't I want to do a environment controller terrain clear data here? So wouldn't I like to do a, instead of a swap channels, we do move data water from source to yeah, that's not, we can't do it like that. Water previous. No, this is correct. Water previous is the water we had previously. So before we began this full process, I think. Yep. And that's okay. But why doesn't this fix it? We try to spread fluid from P to N. It fails. If it fails, we're at an edge. So then we take max. I just have to check this real quick. Yu Xiang, what's up? Why? Let's quit it there. Oh, we end up with this stable. Yeah, that's boring, but okay. Here it works, right? Yeah, the prints slow down this quite a lot. Let's quit here. Let's see if we have something stable. We still have a mismatch here, which bothers me quite a lot. Other than that, it looks good. A little bit of a floating point error here. No, actually not. This one actually has water. Okay, that's without that solution. I should really remove the print as well, but let's do this. Are we done here? We still have a mismatch here, which boggles my mind. Rough edges, because we don't do flip quads anymore. Hopefully we can fix this with some sort of tessellation, but I don't know. Okay, but what the hell do we have here? Water 5490, 54. $61. Water 0 actually. 53, 53, and here we have 54. Why is that? 54. Okay, yeah, I think I know. I'm pretty sure I know. Get neighbors. Here we don't do it with an offset. Or get neighbor. We do get index wrapped X without an offset, and we screw it up. Like we don't, or we compare with twins basically. And if we do it in the wrong or in the wrong order, we get a mismatch like this. Yo, what's up, Diligence? So this is probably not where I want to end up, so this solution is probably not something I want to keep around, but I think we should solve it by doing let's just call it offset 0 by default, 0 by default, offset, and then we do get index wrapped, offset, and then when we do get neighbors here, we do offset 1. That offset is pretty much just to skip twin neighbors. So twins, once again, terrain points. So terrain points that are not the same, but they represent the same point in data space, basically. And we have twins all along the terrain patch borders. I'm interested in this error as well. Oh, really? Oh, never mind, now we have multiple running. Yeah, we could... The fluid solver could probably... It would probably be good to do a second iteration of the fluid solver, unfortunately. Or a improvement iteration, basically. This last addition we add actually adds a lot of unfortunate calculations. Do we have a stable state? Maybe. Nah, even though... Fuck, is this... Yeah, it's slow as hell on the last iteration. Yeah, this one is done, or this one fails way too many times. 5, 6. Yeah, we don't even get the correct values here eventually. Finally finish up find minimas. Check for fluid overflow. Check for fluid overflow. 32 fucking seconds. Are you for real? Yeah, of course. Yeah, it's actually what we do here. Yes. Okay, makes sense. Let me just check one more thing. Let's add this one back and let's let's allow for it to take its time. I want to see terrain fluid solver. Let's sort the log on this one. Find minimas is done, so now we're checking for overflows. And this is, yeah, this is mainly the phase I want to improve upon, because we can, instead of going through each and every point we've already visited, we can just take the ones we haven't visited. The edge point, that is. So this one we can improve the performance of tremendously. Let's quit it here. It's probably gonna try and find minimas. Yeah, it wanna do it. So when we exit it, it wanna do it one last time. Maybe we wanna fix that as well. Extremely slow. And then we check for fluid overflow. The fluid overflow is definitely wrong. Then update stable fluid result. Water 0.4. Yeah, we get the wrong values here. Okay, I'm just pondering here. I might... Okay, bottom line is we have a fluid solver, works very good when we only have one terrain patch. Unfortunately, we have multiple terrain patches. We can fix the communication between terrain patches in a hacky, very computational heavy way. Or instead, we could implement optimization. I've been thinking about implementing for a while. And then we can use that optimization information to traverse patches as well. Hopefully I will have the time this weekend to look into it, so I have a solid plan on Monday. So it's a 50-50 split on Monday. Either we do activation, texture implementation, or we improve the fluid solver. I haven't really decided yet, because unfortunately I got to run now. But yeah, I will have the weekend to think about this. Thank you so much for watching. Appreciate it, and have a great weekend, everybody. Peace.